My name is Parag Jain, and I work as field CTO in Snowflake for data engineering, data lake, MLAI workloads. So today, what we're going to cover is, first we're going to level set on what are storage overview, what are storage options that are there in the market, not just in Snowflake. Then what is Iceberg open table format, how it helps in building Lakehouse. Then we'll see some of the building blocks of data Lakehouse. And then we're going to simplify this architecture, try to build it using Snowflake. Because in Snowflake, everything works, everything is simplified, so we want it to be simplified. We don't want a complex Lakehouse architecture, which other technologies or vendors provide. And then we're going to look at some best practices through a demo. So we are all familiar with all these terms, at least the terms we are familiar with. Databases, which provides a good storage mechanism for your transactions, provides very fast access to write your data through your applications, but it's not very efficient at writing performant query. If you write a query against a database, like for example, Postgres, it's gonna some way or other impact your application, which is sitting on top of the application. That's why you need some sort of data warehouse where you can extract the data from your application, put it in a data warehouse where you can model this data, be it star schema, be it data mesh, be it data fabric, or be it in some other architecture. But it should provide you a way to run faster analytical queries. But it also has problems of scale. We have seen many times that you either have to introduce more clusters, more compute to your database, or increase the size of your storage. That's where data lake comes into picture. You can store large volumes of data. It provides you cost savings. So if you have petabyte scale of data that you want to store, you won't go the database route because it's going to cost you a lot. So you'll probably rest in storing them outside, somewhere in cloud storage or somewhere in your own personal cloud. But again, it has some shortcomings on performance, and it doesn't support multiple engines, so you have to build a Lego structure, build your tooling around it. That's where there is a need for an evolution in the data storage. You need some sort of convergence from data lake and data warehouse. It should be able to support things like asset compliance. It should be able to support semantic layer with verbs like select, update, merge. It should be able to support large-scale data volumes. And then it should always support same governance and security that you want and get from your data warehousing. Things like role-based access control, all that is required. Which leads us to the point where we need a table format. We cannot just store files in data lake, because at some point of time, the data lake will become stale. So we want to create some sort of meta store, some sort of table format on top of that files. This brings us to the Lakehouse aspirations. And why I call it aspiration is because this is what vendors and companies have been selling you, that if you go through the Lakehouse route, we have mastered this, let's store your files in your data lake, let's run this engine on top of it, and then you have your Lakehouse. Well, it's not that easy. You need to have asset compliance. You need to have scale that your company wants, that your data wants. And then you need to have some sort of maintenance activities that you need to do. Like, for example, file compaction, getting rid of old files, bringing in merge to your old data set. You probably need to update your data set, then run multiple engines on top of it to read this data. BI tooling needs to be sorted out. You need to have a right team who knows how to do all these things in your Lakehouse. At the end, you also need some sort of serialized files, cross-platform support, interoperability support, and whatnot. So this way, it becomes very, very complex. So that's why I'm calling it an aspiration. And that brings us to open table format, is how we can turn that aspiration into a running data storage architecture, which we want to call Lakehouse. So keep in mind that in previous slide, we have seen that there is a transition from databases to data warehousing to data lake, and we actually want a combination of all of these. So let's see if Apache Iceberg checks those boxes. First of all, what is Apache Iceberg? Apache Iceberg is an open table format for huge analytical data sets. We are talking about upwards of 100 gigabytes of tables. So if you have any table which has less than 100 gigabytes or is not huge table, don't try to bring it into Iceberg. You will not see the performance benefits over a data cloud or data warehouse or Snowflake native table. If you don't need that table to be interoperable with different technologies, don't try to bring it into Iceberg or don't try to extract that data out of Snowflake. If you do not have any other engines that want to operate on top of that data, don't extract it out. So again, it is for huge analytical data set, provides interoperability. So if you don't need any of those, don't bring your data out. Now let's say you have this huge data lake, which is presently not used, but you have an aspiration that I want this to be open, I want this to be interoperable. We got Apache Iceberg. How does it fit? It provides you many features which were not present in data lake, like schema evolution, like asset compliance, which checks the boxes on databases. It has tool agnostic technology which checks the boxes on data warehousing. It lets you update your data, it lets you merge your data on the same data lake that you have. So it checks all the boxes of a data warehouse capabilities. And thus, it fits right away into a Lakehouse data architecture. Just to summarize, Iceberg table does support things like schema evolution. It's a metadata operation. Now, previous to Iceberg, we have Hive table formats, we have Delta formats. Whenever you write your data into those formats, they have some sort of technical difficulties in evolving a schema, whereas Iceberg right away out of the box supports schema evolution, and it's a metadata operation. We'll see it in a demo as well. It doesn't have any partitioning. All the partitioning is hidden, meaning it's, again, a metadata operation. So today, if you partition your data by day and tomorrow you want to move it to weeks or months, Iceberg supports that through just a metadata operation. It has very fast filtering, and it achieves it through pruning because it collects a lot of metadata about the data that you store in your files. It has safe concurrency, so multiple engines can perform and can read that data without affecting the performance or concurrency of the table. It has many different catalog supports, many open catalogs, like for example, Nessie, HCM, they support Iceberg tables. AWS Glue supports Iceberg table, and Snowflake has also announced Polaris catalog, which is going to be an open catalog, not just an open Git repository, but many other contributors as well. So why choose Iceberg? So Apache Iceberg community has a mix of organizations. We are talking about apples of the world, AWS, Azure, Snowflake including, many other companies are actually contributing to Apache Iceberg community versus a closed gate table format like Delta Lake where all the checks and balances, all the commits has to go through one single company, Databricks. So that's why we have chosen Apache Iceberg, because it has a huge community support. No single company govern Apache Iceberg. It's a mix of organizations. On top of that, it supports DML operations, CRUD operations, data management operations seamlessly without relying on things like Z-ordering, compaction, encryption. All that is supported through Iceberg. So just to recap, we have seen that evolution from data lake to databases to data lake. And now we are at a point where we want to converge all that together into a lakehouse. We have also seen how Iceberg fits right away into the data lakehouse pattern. It provides you best of data warehouse, data lake, and databases. So you do not have to worry about that whether my architecture is going to be future-proof or not. So let's move forward and learn some building blocks of Lakehouse and how Snowflake supports that. These are basic building blocks to support end-to-end platform required for Lakehouse. So if we go all the way towards the left to the sources, we have many sources, and not all data looks and generate the same way. It can be structured, it can be semi-structured, it can be unstructured. So all that data is generated in a different way. So you need a place to store this data, and you need a place that can scale the storage. What's best than cloud storage? So Azure provides ADLS, Blob Store, AWS provides S3. These are all very flexible storage. You can store any type of data in blocks in these object stores. Moving slightly to the right, you need a compute engine which can not only just perform ingestion, but also is very efficient in transformations. It should have some sort of connectors to connect to the sources. It should give you governance, security, and some sort of cataloging support, metadata store support. And on top of that, it should be able to operate on your storage of your choice, where you can store your Iceberg tables or store your Lakehouse data. On the very right-hand side, the platform should also support BI analytical tools. It should give you some sort of collaboration, data sharing capabilities. And then in the end, it should also support your advanced analytical use cases like AI and ML. Now you see there are many building blocks in Lakehouse. It's not just putting your data in the data lake and running an engine on top of that, right? And everywhere there you see the warning sign or the caution sign is where you should pay attention to. Many platforms do not come built in with governance, with security. They do not come built in with data sharing capabilities, collaboration capabilities. Many platforms do not provide you write-out access to encrypt your data, to compact your data on your storage. Then there are many platforms which comes with various computational options. They are far too many, but then you have to pick and choose. Then you have to pull the levers to make everything works. Snowflake solves this problem by bringing in best-in-class features to support Lakehouse. These are some of the key components that you will use if you build a Lakehouse on Snowflake. All these features underpinned by the same governance layer. So you see Snowflake Horizon that will provide you a simplified governance across all these features. You can not only ingest data through Snowflake features, but also transform in your own programming language using Python, Java, or just plain old SQL to build a pipeline. It will give you a way to actually create a continuous pipeline. So as your data comes in, you can build on top of the Lakehouse that you have already built through building continuous pipeline. Not only that, once your data is there in the Lakehouse, in your own chosen storage, Snowflake will let you collaborate on that data. It will let you share that data within your team. It will let you build applications through native apps and SPCS. It will let you run AI ML jobs on the same data set. And it will let you store not just structured data, but unstructured and semi-structured data as well. So where does Iceberg fits into this? So if you see at the bottom in the open storage, now Snowflake provides you an option to store your data into Iceberg, which ultimately gets loaded into your own chosen storage, which is basically cloud storage buckets. For a Lakehouse, there are three primary layers: the storage layer, the processing layer, and then the consumption layer. The consumption layer should also have a governance. It cannot, we cannot go let people consume this data without any governance. We need that. So it should have some consumption and governance as well. The storage layer should be cost effective. Again, we are using cloud computing storage layers, so those layers are cost effective. Sometimes they give you bigger discounts as well than what Snowflake gets. So for example, if you're storing petabyte scale data set, you might get a better discount from AWS, you might get a better discount from GCP or Azure, and you want to take advantage of that storage discounts. So you can choose your own storage layer. What Snowflake offers you is a very fast computing layer, which can run concurrently on the data set. So your BI layer can interact with the same compute layer, your processing and transformation or data engineering layer. The data engineers can interact with the same high power compute layer as well. Once you build your Lakehouse in Snowflake, you will be able to interoperate on that data. So all the boxes that you see in orange is your managed query engines, your managed catalog services, customer managed open storage. What Snowflake provides is the same simplified governance and compute to consume this data and build upon the Lakehouse architecture. It also offers you flexibility and interoperability with Iceberg catalog support. So once you build your Iceberg table, you can not only just use Snowflake, but other platforms and tools like, for example, Spark, Trino, to connect with that Iceberg data without going through Snowflake. So you can use the external engine and run that on top of the Iceberg tables that you created through Snowflake. We are also going to offer Polaris catalog, which will support multiple engines using the Apache Iceberg REST API framework. So in future, and very near future, you will be able to have bring your own catalog to Polaris or use Polaris as a mechanism to connect with Snowflake managed Iceberg tables. What Snowflake offers is ease of use, governance, and full platform capabilities. So the difference between creating an Iceberg table through other tools or through Snowflake is we have all these enhancements built into Snowflake, which are now available to you through Iceberg as well. You do not have to bring in different Lego pieces to build your architecture. You can just use Snowflake for DDL, DML operations. You can use Snowflake for writing metadata back on your storage, so you do not have to connect through Snowflake for your external engines. So it does provide a true open Lakehouse architecture through Snowflake. If at all you have to use Snowflake with some external catalogs, meaning some other engines manage your Iceberg tables, you can also use Snowflake to read that data. So it's not just everything is through Snowflake. Now you can connect to other Iceberg tables using Snowflake as well. Once you have figured out what data that you want to expose through Snowflake to your end user, you can build gold layer or gold tables or platinum tables on top of it and use that in your Lakehouse pattern. What you get is better query performance, much more efficiency, built-in governance, and role-based access control. So if you have built your Iceberg tables outside of Snowflake and you want to get that data into Snowflake, that's also possible through Snowflake. What it actually gives you is almost 2x performance benefits versus using external tables. So if you have some Parquet data, let's say, for example, you have no Iceberg table. Snowflake does have a way to convert that Parquet data into an Iceberg table format without actually moving data around. This way, instead of just interacting with the external files, like let's say, for example, Parquet, you can just use an Iceberg metadata, lay over an Iceberg metadata on top of it, and increase the performance by 2 times. That's what we have tested, and it works. If in future you decide that, hey, let's create a table, let's create a model using Lakehouse on top of the data lake files that we have, instead of 2x performance, you might get up to 4x performance benefits by creating an Iceberg table, a real Iceberg table on top of the data that is saved in the data lake. Apparently, what we have seen is, if done right, the Iceberg table created through Snowflake have almost parity with Snowflake native tables in terms of performance and cost. This is just a reference architecture, all things combined, how the Snowflake architecture will look like, how your consumption layer will look like, how your processing layer will look like, and how your storage layer will look like. And on the right-hand side, you will see other interoperable engines, and that layer is expanding with Polaris. We are going to bring more interoperable engines like Dremio, AWS Athena, Azure, Microsoft. Many other companies are joining the Polaris bus, and then you will see the consumption layer growing because Iceberg is growing. So let's just quickly summarize before we jump onto the demo. What we have seen is we are not trying to prescribe you to create a lakehouse. We are trying to prescribe you is just try to balance your act. Try to see if you really need a lakehouse. I know vendors are trying to sell you the lakehouse concept. Some say that we mastered it, but it's not the case. It should suit your needs. The storage layer should be open. It should support multiple file formats. It should support multiple ingestion mechanism. It should support multiple engines on top of it. It should not be just one engine which is running on top of Lakehouse. Otherwise, it is not truly an open Lakehouse. For transformation, Snowflake does offer many programming capabilities, plus built-in dynamic table pipelines, built-in DAGs. So you don't have to look for things like Airflow, dbt, or any other engines on top of your Lakehouse. You can do that through Snowflake itself. For processing and transformation, you can use things like UDF, UDTF, stored procedures, or simple SQL to orchestrate the pipeline. All right, so let's quickly jump onto a demo. All right, so I have some raw data saved in my S3 bucket. This is in JSON format. I want to make sure that I create an Iceberg table using this data. For the demo, this is a really small data set. Like I said, Iceberg is really meant for a huge analytical data set. But just for this demo, we have little time, so I'm just going to go over and use this small data set to create a table. Just to give you a taste of what Iceberg table and Lakehouse with Iceberg table looks like. Creating an Iceberg table with Snowflake or creating a Lakehouse with Snowflake is super easy. You just need to tell Snowflake where your data is and what role should it use to connect to it. It's a simple 5-minute process to connect your Snowflake to your object store. And you don't really need user IDs and passwords to share your data because they change. So what you can do is Snowflake can actually interact with your cloud services and get access to that data without actually using a username and password. So once you're connected, you can actually see your data. So this is my data, sales data.json. I've created a stage around it. A stage is basically a built-in object in Snowflake which talks to your storage. I'll tell the stage that this file that I'm trying to deal with is a JSON file. Again, very simple. These are all built-in objects. They are saved in Snowflake, so you only create them once and use it over and over. So my raw data looks like JSON. I want to create a silver layer on top of that. For that, I need an Iceberg table because I don't want to create a native Snowflake table. This data has a place in object store. All the consumption is done through object store. Not many consumers on Snowflake side. That's why I want to create a Lakehouse outside of Snowflake. So I'll quickly create an Iceberg table, which will follow the structure of my data. So if I look closely, I have a customer ID column, customer name column, and purchases that they have made. So this is sales data, basically what my customers are buying, what is their name, what products they are buying, that sort of information. I'll quickly load the JSON data or raw data into my Iceberg table. Now this can be a recurring exercise. This can be a continuous pipe built on top of your data. As and when files are dropped, we are copying this data into our silver layer. And just like that, if I go back, there you go. Now I have my data saved in this location for my Iceberg table. And this is my silver table. So let's quickly check. There you go. I have my data and my metadata saved inside Snowflake. Now, this is my silver layer. Now, if I want to interact with this silver layer through some other tools, like for example, Spark, I have a Spark notebook running here. So let's see if I'm able to connect to this data. Again, I'm using Spark and Apache Iceberg SDK to connect with the data. There, you just need to provide the Snowflake URL, username, and password to interact with this data. I am not going to use Snowflake Compute for this. I'm going to use Spark Compute for this operation. But I need to point my Spark to a Snowflake catalog. That's all I'm doing. There is no consumption. There is zero cost from Snowflake side. So I'm going in my namespace, and I can see that there is now a table called Snow Iceberg Sales Raw. And let me just increase the size a little bit. Right. I can not only just see that table, but I can also interact with it. So for example, this cell is done. If you see here, I'm trying to grab 10 rows out of that data set, and then see if I can load it into, there you go, and see if I can load it into a Spark data frame, and then use that data frame to show. There you go. I can not only just get that data into Spark data frame, I can do some analytics on it. So I want to find out any customer greater than 1,500. There is none, so let's change this to 100. Just 10. There you go. There's so many customers with customer ID less than 100. We can also things like print schema. So you see how we can interact with an Iceberg table created by Snowflake outside of Snowflake, right? And it's all interacting with your bucket directly. So let's move forward. We just created a silver layer. I want to do more. I want to create a golden layer as well in Snowflake to complete the Lakehouse architecture. If we see the silver layer, we have there you go. This is my silver layer. Let's limit to 10. If you see in my silver layer, I have customer ID, customer name, but then my purchases are in this nested structure. I want to unnest this and create a better row column type outlook so that I can share this gold layer with my end users or end customers. So for this, I have a simple query. Snowflake can do this through its engine. It can flatten this data using simple dot notations. So I'm pulling out this information, and while I'm pulling out this information, I'm also transforming the data type to what I want. So let's build an Iceberg table with gold layer and with the data that we want. While we are creating the Iceberg table, you can actually do a CTAS operation. So you can provide your select script as you're building your Iceberg table. Again, similar to what you used to do in Snowflake native table, all those capabilities are available in Iceberg table as well. So we are using that CTAS operation to build this table. Let's build it. And now let's go back and see if we have, there you go. Now we have the transform gold layer as well in our cloud storage. And we have all the metadata that we need to interact with this Iceberg table in cloud storage through Spark. So let's see if we can see this table now in Iceberg. So this is my Spark session. I'm going to run show tables again. We only had one table before, so let's see if Spark can get to, there you go. Spark now can identify the second table that I just created. So it's not just Snowflake, but other tools, other engines can also interact with Iceberg table that is created by Snowflake. So it is truly open. And in a click of a button, basically, you don't have to drop your metadata, update your metadata, or update your engine to interact with the Lakehouse tables. It just appears. Now let's not stop just here. Let's prove out that Iceberg table is the right fit for Lakehouse. Now, in the beginning of the session, I mentioned that for a Lakehouse to actually work, you just don't need a data lake. You need warehouse capabilities. You need database capabilities, like, for example, asset compliance, updates, inserts, merge, all that statements to your table as well. So here, let's update our table. Let's see how fast it is, because Iceberg promises that it's just a metadata operation. So let's see, we have, in our golden layer, we have something called a sales price and quantity. So the sale price and quantity can give us a unit price. So let's try to add that column in our table at runtime. There you go. So we just added a column called unit price. Let's see if it is there in our table now. Yes, so unit price is there, but there is no data in it. Right, so let's try to seed this data through an update statement. What we are going to do is unit price is equal to sales price divided by quantity, fairly simple. Let's seed that. There we go. It's done. Now let's see if this is available. Okay, this is description. There you go. So now we have unit price updated in our table. Now let's see if we have, first of all, let's see if we have any data changes. So now we have another file created just now because we added new column. So it not only had the old file, but now the new file as well. And then if we go to metadata, there you go. There are new metadata available for us to interact with. So we started with one metadata JSON file, and now we have another metadata JSON file. So it is truly just a metadata operation to update a table versus creating or restructuring or repartitioning the whole table. So it's simple in Iceberg, and it does provide that true Lakehouse capabilities. Now, let's not stop there. Let's see if we are able to time travel on our data. So the same table, same gold layer. Let's see what it looks like 1 minute ago. Let's change this to maybe 4. There you go. So 4 minutes ago, the table did not have anything in the unit price, but now, so if you go back 1 minute ago, now it has data. So Iceberg does provide that time travel capabilities as well, similar to what Snowflake native table does. And there are many more capabilities which are compatible with Iceberg format, so you truly get the same view of data, whether or not you're storing it in Snowflake or outside of Snowflake. Now, there are some things that you have to be aware of. Whenever you interact with an external applications, external engine, you have to give access to the buckets. You manage role-based access control, or you manage the control of these buckets to different engines. That is not through Snowflake because you are not interacting with Snowflake engine. Polaris Iceberg catalog will change that in some sort, but managing your storage bucket is customer's responsibility. It comes with Iceberg. What Iceberg does is it provides table format, file format, and catalog specification. It do not implement any catalog. That is very important to understand. That is one reason why Snowflake has to create a Snowflake managed catalog. That's one reason why Snowflake is going for Polaris catalog to enable some sort of federated access to the catalog. So keep in mind, Iceberg do not come with a catalog. That's why we have to implement our own. There are some monitoring capabilities that Snowflake provides. You can run various queries to find out. You don't have to actually go to your cloud bucket to find out how much data you have in your table. You can interact through Snowflake and find out, like for example, column formats, table formats about your data, how much, what sort of data types you have in your data. You can run and find matrices around your table usage, your storage metrics, how much data you saved in cloud storage, how is it growing. All that information you can get through the catalog. So all that metadata is available through Snowflake as well. Various versions that you have saved, what time you have saved, what time the table was dropped. All that information is available through Snowflake as well. Thank you so much, guys.